Richard Oppenlander and others say the most powerful thing we can do to stop climate change is stop eating animal products. Is this true? And if so, aren't more people speaking about this? Or why aren't more people speaking about this?
Well, I think a lot of people do actually speak about the fact that a meat-based diet has a very heavy footprint on the planet. And that's why there's been so much encouragement of going vegetarian or vegan. On a personal basis, that is probably the single thing that you can do that would decrease the size of your footprint the most. And so that's fine, but that's not going to stop the use of fossil fuels. So we do need to influence the politics as long as we're not making fossil fuels pay their cost to society and in fact subsidizing them, then we can't solve the problem. And our individual actions, even changing our diet in the most extreme ways, is not going to solve the problem. So those things can be encouraged, but that's not enough.
What proof do you have for people that say climate change is natural?
Well, climate change is natural. And that's actually what informs us. You know, we can use those natural variations to understand how big a change you will get for a given change of the forcing factors. The climate of Earth has changed enormously over time, associated with, primarily with, the change of the amount of carbon dioxide in the atmosphere. So, and there are other forcing factors that can change the climate, and they're very useful. Large volcanoes, for example, reduce the amount of sunlight coming in, and they cause a cooling. And we're able to test our climate models by using these natural experiments. And what they tell us is that the climate system is very sensitive. And now humans have become the biggest forcing factor. We can now measure, we measure very accurately how CO2 is changing, how methane is changing, and we can measure how the sun is changing. There's a solar cycle. The sun becomes brighter and dimmer with a 11-year cycle, and it may have longer-term variations also. But that's how we understand, by using these natural variations. That helps us understand the system and check our models and compare the natural changes with the human-caused ones. And humans have become, by far, the biggest source of change.
What are the results of climate change so far in terms of its impact on melting ice caps or glaciers, and why does that matter?
Well, the effect of climate on ice, on glaciers, on ice sheets, on snow, and on permafrost is now very apparent. And we can see in the glaciers, for example, Glacier National Park, within a few decades will have very little ice, if any. It will become a misnomer. Switzerland, the famous glaciers there are receding rapidly. So there's no doubt about what's happening. And we see permafrost, beginning to melt at the southern borders of the frozen ground region in Canada and Alaska and Siberia. And most dangerous and most concerning is the change on the ice sheets on Greenland and especially Antarctica, where the ice sheets are losing mass. And there are two effects of global warming on the ice sheets. One is you get more snowfall. so they grow faster in the center. But we get more melting around the edges. Well, we now have, so there had been some puzzlement about, well, what's going to be the net effect of those two things? Common sense would tell you if the planet gets warmer, then probably the ice sheets are going to get smaller. But the time scale of that may not, we're changing the climate so fast that it could, conceivable if the ice sheets are very stiff, that increased snowfall is actually going to allow them to grow. And some people actually thought that. Well, now we have the answer. Because of this remarkable little satellite, a pair of satellites called the gravity satellite, which can measure the Earth's gravitational field so precisely that you can see the change of the mass of the Greenland ice sheet and the Antarctic ice sheet. And what we see is that they're both shrinking. They're now shrinking at a rate of a few hundred gigatons, billion tons of ice per year, which is, sounds like a lot. It's enough to cause so that sea level, all the processes together are causing sea level to rise about a little more than 3 millimeters a year, which is not negligible, but is not yet a big practical problem. It has caused a sea level rise of about a foot over the last century. But that's the real issue is what is going to be the change in the future. And the rate of melting keeps increasing. So that is the big threat. That's why we need to reduce emissions to avoid instability and sea level rise of many meters.
What are the results of climate change so far in terms of its impact on ocean acidification, and why does that matter?
Well, the change of ocean acidification is not a climate change, it's a change due to the carbon dioxide. So it has the same source as the climate change, the increasing CO2 in the atmosphere. Much of it, about a third of it, is going into the ocean, where it's carbonic acid. It increases the acidification of the ocean, and that, combined with the rising temperature in the upper layers of the ocean, is having an effect on the biology of the ocean, and especially the coral reefs, which are being stressed by those two factors, the rising temperature and the acidification, and other things that humans are doing, so that we are losing coral reefs at a pretty rapid rate. And we don't want that to happen because there are so many species, millions of species associated with the coral reefs. They're the rainforest of the ocean. And so we need to preserve them, and we can't. If we bring the emissions under control so the temperature stabilizes, then we can still save these remarkable parts of our natural system. So we don't want to leave the impression of this is gloom and doom, that we're necessarily going to be losing these things, because that's not essential. But we do have to change our energy path if we want to preserve them.